Today I'm here to talk again about Spring. In particular, I'm going to talk about cloud-native applications, how to build them and how to deploy them using Spring Boot and Kubernetes. I work as a senior software engineer at Systematic, a Danish software company in Aarhus. I'm really passionate about anything cloud-native. I'm even writing a book about this subject. It's called Cloud-Native Spring in Action with Spring Boot and Kubernetes. Working right now on the last chapter, so almost finished. It's currently available as early access. Yeah. I'm also a big supporter of open source technologies. I like contributing as much as I can. In particular, I contribute to Spring Security and Spring Cloud. So, cloud native. Before even talking about technologies, why cloud native matters? So why, as a business, as a company, we want to investigate cloud native technologies? And the reason is that cloud native technologies empower organizations to achieve certain goals that we really like when we talk about modern applications. First of all, cloud native technologies can help us delivering software faster and in a more flexible way. We can build software which is more resilient, meaning that even in the face of failures, the services that we are offering our users are still available. So users can really continue using our applications. At most, we need to ensure a graceful degradation of functionality, so we don't want to disrupt entirely the experience for our users. Then we want to be able to scale to reach new users, but also to adapt with new devices. Just think about IoT devices and a new amount of data flowing through our system. Cloud-native technologies can help us with that as well. And all of this, we want to achieve it while optimizing costs. So we want to do it in an efficient way and pay just for the actual resources that we are using and taking advantage of the elasticity features of cloud infrastructures. Today, I'd like to go on a journey with you from development to production. We're going to start by building a cloud-native application using Spring Boot, which is a great framework focusing on productivity and simplicity. After that, we're going to containerize the application. We're going to package it as a container image using Cloud Native Build Packs, a project hosted at Cloud Native Computing Foundation and focused on transforming application source code into container images. And finally, we're going to deploy the application on Kubernetes, on an actual Kubernetes cluster in a public cloud. So let's get started with this Cloud Native journey. And the first step is Cloud Native development. We want to build a Cloud Native application. The starting point is start.spring.io. From this page, we can initialize a new Spring Boot project. Raise your hand if you have worked with Spring Boot before. Nice. So from here, you can start a new Spring Boot project. There's also integrations with several IDEs, so you don't have to necessarily use the web page. I could do it also from IntelliJ, for example. And from here, I will initialize a new Gradle project. I'm going to use Java, but you can also use Kotlin and Groovy when working with Spring. I'm going to choose Spring Boot 2.6, the latest release candidate version. And the application we're going to build is called Demo Service. Also, I want to use the latest and greatest Java 17. The application will be very simple from a business logic point of view. It will expose an HTTP endpoint that returns a message that we want to be able to configure depending on the environment where we deploy the application. We have two main options when we build web applications. We have the servlet stack and the reactive stack. The servlet stack is based on the Java Servlet API. The default embedded server is Tomcat. So I could add the Spring Web dependency in order to achieve that. The other alternative is Spring Reactive Web. It's built on a reactive stack. When you have applications which are I/O bounded, there's a lot of intensive operations involving databases and other services. Reactive can really help us achieve applications which are more scalable, more resilient, and more efficient. And all three are goals of moving to cloud native. So it's a perfect use case. So I'm going to use Spring Reactive Web. Next, since I want to go to production, I need to consider how I'm going to maintain and observe the application in production. So for that reason, I'm going to add also Spring Boot Actuator to the project, which exposes a lot of useful endpoints in order to monitor and manage the application. So for example, endpoints returning the application health information or metrics. And regarding metrics, I'll also add a Prometheus, so that from Spring Boot Actuator, I'll get out of the box an endpoint returning Prometheus metrics, which is also something that I really like in a production-ready application. At this point, we are done. I can generate the project and open it in my IDE. And I have already done that, so let's move there. So this is an empty Spring Boot project. We just have a main method initializing the application, and now we can start implementing the business logic. So we said we want to expose an HTTP endpoint, so I'm going to define a REST controller class. Let's call it demo controller. And then we want to handle GET request to the root endpoint. So whenever we send the GET request to the root endpoint, I want to return a message of type string, but I'm working with Reactive Spring. So I can't return just a string, I need to use a reactive type. There are two reactive types. The one we're gonna use here is a mono, so I can say mono of string, and you can think of it as an optional. It means either 0 or 1 value. The other type is flux. You can think of it as a collection, but it's actually an asynchronous type, so it's a publisher. It means that eventually we're gonna get several values. But in this case, we are going to return only one value, so I'm going to use the mono type. So mono of string, and then get message. And if I want to return a mono from a fixed string, I can say mono.just, and then the string, for example, Spring Boot on the cloud. And this is fine. I can deploy the application, I can call the endpoint, and I get the message back. But I'm not really happy with it because I want to be able to change the message depending on where I'm deploying the application. And I don't really want to go back to the code and every time change and recompile the whole thing. So we need externalized configuration, which is an important principle of cloud-native applications. Instead of having a lot of things packaged inside the application, we want to make it possible to configure from the outside everything that might change between deployments. And that's how the 12-factor methodology also defines configuration. So in Spring Boot, we have several ways of handling externalized configuration. A simple way now is going to the property file, and I'm using the YAML property format. And in here, I define a new custom property. Let's call it demo message. Now, the value is the same here. But since I'm using a property file now, it means that when I deploy the application, I can override the value through environment variable, through JVM system properties, through ConfigMaps in Kubernetes, and we'll see that later. But first, I need to actually get the value from the property, right? Because I'm still using the hard-coded value. So let's keep the property file down here. And one way to parse the property is defining a configuration properties bin. There is an annotation for that, and I can use either a Java class or a record. I'm using Java 17. I really like to use a record here, so I'll say record demo properties, and this bin will have only one field for now called message. And then I want to tell Spring Boot that this record should give access to all the properties with the prefix demo, not just any properties. So by combining the prefix and the field name, we get access to the property. The final step is actually telling Spring Boot that it needs to look in the class path for these configuration properties bins. So I'll use a configuration property scan annotation. Like that. And that's it. So now this demo properties record is actually a Spring bin, so I can inject it anywhere I need that value. So I'll do that in demo controller, private final demo properties, and I'm going to use constructor injection. And finally, I can replace the hard-coded message with demo properties message. So we have now externalized the configuration. If I deploy the application, I can override the value in different ways. So that's what I wanted. It's perfect, but still, I don't know if it works. Now, the business logic in this example is super simple, but we want to go to production. So it's important that we ensure the quality of the application. That means we need auto test. So let's have a look at that. We have already a test class, which is generated when you initialize a project from start.spring.io. And I can set up tests in different ways. In this specific scenario, I want to define some integration test. It means that I want the full application to run and run test against it. So I can use the Spring Boot test annotation in order to initialize a full Spring context, and also configuring the web environment so that I get also a web server exposing its services through a random port, because I really don't care about the port. So now I have a setup for full integration test. It means that an application will run. And I can start writing some test cases. For example, I can say that when I send a GET request to the root endpoint, then I want to ensure that the message is returned. And the way I call the application is via a web test client object. This is an object that is part of the Reactive Spring stack, but you can actually use it also if you're working with a traditional servlet application. It's a really convenient utility. Maybe you are familiar with the test REST template. This one is a better replacement because REST template is now deprecated, so it will not contain any new changes in future versions of Spring. So now it's a good idea to move to web test client and web client also in a servlet-based application. It doesn't have to be reactive. I'm using it in a reactive application now, but that's just one of the options that you have. So now I use web test client to send a GET request to the root endpoint. And then I send the request with exchange. And finally, I want to assert that the status of the response is 200 OK, and that the body is a string, and is equal to the value that we defined in the property file. Like that. So I can run the test now. This will spin up a full application. So if we go through one more time, we send a GET request, root endpoint. With exchange, we send a request. Exchange is how we call request in a reactive context. They're called exchanges. We expect the status to be OK, and we expect the body to be a string equal to the property we defined in application YAML. So this Spring Boot on the cloud. And the test is green. So we are getting closer to be ready to deploy the application. But we need to consider how to package it. Cloud-native applications are supposed to be self-contained and standalone. So we don't want any external dependencies. Traditional applications would be packaged, for example, as WAR file or EAR files, and then deployed to a web server like Tomcat or an application server like Wildfly. We don't want to do that with Cloud-native. We want to have one single executable that contains all the dependencies that are needed by the application to run. But we allow only one external dependency, which is the runtime environment. In this case, the Java runtime environment. Besides that, everything else should be packaged together. In Java, we do that via jar packaging. So we can package our application as a jar file, also called a fat jar or uber jar, because it contains everything within, also an embedded web server. Now, using either Gradle or Maven, I can run a task and package the application as a jar. In Gradle, I would do that with boot jar. And once I get the jar file, I can run it as a standard Java application. So java-jar, and then pointing to the jar that I just generated. And this will run the application. We can also see if it works fine. So we have HTTP. Yes. So I'm not using curl, I'm using HTTP, which is a very convenient utility. It's like curl, but for humans. It's really great. So I can send HTTP column 8080 means that I'm sending a request to localhost 8080, which is the port used by Spring Boot by default, and then the root endpoint. And I get the message back. Spring Boot on the cloud. So let's recap what we have done so far. So we talked about self-contained application. So we want applications which have no external dependencies besides the runtime environment. We use the jar packaging. We also call them uberjar or fatjar. That's the default behavior in Spring Boot. So we don't need any extra configuration. And then we briefly talked about externalized configuration. And in particular, property files which are packaged within the application are really convenient in order to define some default values, or even as a sort of documentation of what are the capabilities of the application, so which configuration properties we might define. Also, we saw that it's very easy to package the application as a jar. We can do that either with Gradle or with Maven. We have a simple task for both cases. And we might be done. So depending on the deployment platform, we can, for example, take this jar file now and deploy it on Heroku or Cloud Foundry. And that would be it. But in our case, we want to move to Kubernetes. So we need to containerize the application. We need to package it as a container image. And writing specifically Docker files in order to build container images is quite easy. But doing that for production is really not, because there are so many things we should consider. First of all, we shouldn't use fat jars. That's a common mistake. So now that we have a jar, we might think, now let's move it inside the image and it's done. We don't want to do that. It's not efficient, because every time we change maybe one line in our code, the whole jar file needs to be replaced in the image. And that's not efficient. That brings us to performance. Both at build time and runtime, we really want to focus on performance. We don't want to wait too much to build the container image, or even at runtime when we have to, for example, pull the image from the registry every time we have a new update. So it's better if we leverage the layering part of the images. So if we open up the jar file and put all the libraries inside Spring and our own code in different layers, then we get a better and more efficient image. And finally, we need to consider security. So for example, we don't want to run a container as root, and that's actually the default in Dockerfile if you don't do anything about it. And we don't want to include secrets. Even if one of the upper layer you remove a secret, the layer below will still contain the secret. So no passwords, no private keys. It's really important that we take care of that. Still about security, we need to consider whenever new vulnerabilities is patched, establishing a process in order to patch all our images. So how can we deal with this containerization process? And especially as a developer, I don't want to spend too much time on it. I want to focus on the business logic. So sure, I can use a Docker file, and that's super flexible because I can control every little aspect of the image. But there are tools that can help us containerize the application without writing a Docker file. For Java applications, we have Jeep, for example. A tool developed by Google is available as a Gradle and Maven plugin, and you can containerize your Java application without a Docker file. But today I'm going to talk about Cloud Native Buildpacks, which is a specification hosted at the Cloud Native Computing Foundation to transform application source code into container images. And this specification comes from years of experience by Heroku and Vitale in order to package jar, in particular Java applications, into container images. This is now a specification and works for any type of application. So you can actually use it for any kind of language and framework. But we need an implementation first. This is just a specification. One implementation is Paketo. Paketo provides build packs for different languages and frameworks. So you can use this same implementation for your Java application, for your GraalVM native images also. You can use it for Python, for Node.js, for Ruby. When we use Spring Boot, the great thing is that we don't even have to think about it. We don't have to install anything else because it's already included in the Spring Boot plugin for Gradle and for Maven. So if you remember, we packaged the application as a jar file in a very easy way from Gradle. For container images, we can do the same. It's just a different task. It's really simple. Under the hood, Cloud Native Buildpacks is used, in particular the Paketo implementation. So let's have a look at how it works. So I'll stop the application first. And then I can run boot build image. I'm relying on the default configuration now, but of course, following the Spring Boot philosophy is completely customizable. Let's see. Oh, maybe we are not connected to internet. Yes, let me switch the network. Yeah, this is the fun part of doing live coding. I love it. Yes. Take two. Okay, now it's going through. So it's building the image. I was saying that we can customize it in different ways, and we can even use the same task to publish the image. So what I have done in order to automate a lot of things in the spirit of a cloud native, it didn't work again. Okay, take 3. And in the meantime, I'll show you on GitHub. I have all these source code examples. And in particular, I'm using GitHub Actions in order to define a continuous delivery pipeline. So every time I push some code, maybe. Yes. I have a delivery pipeline. Let's hope internet will work fine. Yeah. Every time I push something new to GitHub, that task is executed in order to containerize my application and publish it directly to my Docker Hub registry. So this is really unfortunate. Yes, I'm using my hotspot, but I'll move on to... Let's see. Okay. Or maybe not. Yes. So I'm using GitHub Actions. Super slow. Yeah, that will not work out. Well, I'll show you that later, but let's move on. So I know that I push my changes to GitHub, so we get this image published to my Docker registry. After that, we are ready to move to Kubernetes. So we have the container image. I have established already a Kubernetes cluster on a public cloud on Azure. And in particular, I used an open source Kubernetes platform. It's called VMware Tanzu Community Edition. It's open source, it's free. I used it to deploy this cluster on Azure. It contains a lot of nice features, and one of them is that it allows me to use Knative. Knative is a layer built on top of Kubernetes that, among the other things, provides a better developer experience and also extra functionalities. For example, it introduces support for serverless workloads and event-driven. So one of the nice features of Knative is that you get the scale to 0 feature. So if your application has no request to handle, it scales to 0 instances. And that's very useful if you're working with serverless applications. So now I'm gonna, yes. Well, we'll try later. So now what we want to do is doing some YAML coding. That's even more fun than Java-like coding. So I have a YAML file here. So let's start by defining how or what we want to achieve in Kubernetes, because we use a declarative way. So we define what we want to achieve, and then Kubernetes figures out how to achieve it. So I'll start by adding the API version. The deployment resource in Kubernetes is the one that controls how we want to deploy the application. So it makes sure that the application is up and running. If something goes wrong, it self-heal, and all the nice features that we like from Kubernetes. Let's call it demo service. And then we need to specify how the container should be built. So we have containers, and the name of the container will be demo service, and the image is the one that my continuous delivery pipeline published to Docker Hub. Demo service GOTO 1.0. So far, I have described a deployment object. It's a standard Kubernetes resource. So I could now apply this resource to the cluster, but then I would still need 2 extra resources in order to use it. I would need a service resource to expose the application inside the cluster, and then I would need an ingress resource to expose the application outside the cluster. And I don't really want to deal with 3 different resources, so since I have Knative, I want to let Knative deal with that. So instead of doing this deployment resource manifest right now, I will switch to use Knative, the Knative API. And I just need to change API version and kind. So now this is a Knative service resource. And the specification here is the same that we would use in a deployment. So what I'm gonna show you here, you can do it also on a deployment directly. But the nice thing is that when I deploy it, I will also get a service and an ingress controller, so I can directly use the application without writing additional manifest. But right now, this works. Of course, it's good for development, but it's not ready for production. So now we're gonna start iterating through it and see how can we make it ready for production. The first thing to consider is that containers need CPU and memory, of course, to run. We are on a cluster where each container will compete against each other for those resources. So we need to be clear about what are the requirements for each container in order to run, and what are the limits. So we can add a request, not the request, a resources section. And we have 2 types of resources, the requests and the limits. The requests are the minimum resources that the container needs in order to be able to run. So they are the resources that Kubernetes guarantees that they will be available to the container. And then each container can use up to the resources that are defined as limits. So for the memory part, I can assign values in both for request and limits. And now for Java applications based on the JVM, we notice that we get better performance if we assign the same value both as request and limits, because the JVM doesn't react very well when the container around it keeps changing the memory. So I'm going to assign the same value in both places. And then for the CPU, I'll define some request for maybe half a CPU, and then I'll leave the limit unbounded, so that if there's available CPU, I want the container to use it. These 2 resources are really different, so we need to consider them in a different way. First, the CPU is a compressible resource. So when we hit the limit, then the process is throttled, but the application will still run, maybe with lower performance, but there would be no error. The application will still be running correctly. Instead, memory is a non-compressible resource. So if we hit the limit, we get the dreadful out-of-memory killed error, which is the worst. So we really want to avoid that. And in Kubernetes, of course, as I said, we can assign both CPU and memory as request and as limits. But I would say that we should pay particular attention to the memory here. Next, let's talk a bit more about externalized configuration. We saw that in Spring Boot we can define some custom properties. We have a value now in a property file. What we want to do now is overriding some of that configuration in Kubernetes using ConfigMaps. When we build cloud-native application, it's important to distinguish between code, credentials, and configuration. They should be always in parallel tracks. So we have already the code. For configuration and credentials, Kubernetes conveniently offers us the ConfigMaps resources and secrets resources. Today I'm going to show you how to use ConfigMaps. From a Spring Boot point of view, secrets work the same way, but I won't go deeper in that, but just let me say that secrets in Kubernetes are not secret. they're just plain text. Even if they are encoded in base64, they're basically plain text. So what makes a secret is how we handle it. But just the resource itself is not a secret, so be careful about that. In Spring Boot, we have different configuration options. We talked about the basic ones. We have property files. We can use environment variables and maybe some command line arguments to override properties. But we can also use some configuration services. So for example, if you have already a console or Apache Zookeeper infrastructure, you might want to use some of the projects provided by Spring Cloud in order to use that infrastructure to also store configuration. Or you could run a Spring Cloud config server. If you're running on a public cloud platform, maybe that platform already provides some services regarding configuration and secrets management. So you might think of using those. For example, on Azure, I could use the Spring Cloud Azure project in order to integrate seamlessly with Azure and get configuration from Azure Key Vault. And then finally, Kubernetes. Kubernetes is what we are working with right now, so we can use ConfigMaps, Secrets, and also environment variables. Between environment variables and ConfigMaps and Secrets, we're gonna see some differences a bit later. So now let's create a config map. So yay, more YAML. So we have an API version v1 kind config map. And the name will be demo config. Now, in a config map, we can write key value pairs, of course, but we can even embed some configuration files. So if we work with Spring Boot, we are used to work with property files. So I can embed a property file directly, so I don't have to come up with different syntaxes. So I will say application.yaml, and then I can embed a property file in here. If you're using something like Customize, you can even automate the generation of a config map starting from a property file, which is really convenient. The first thing I want to do here is overriding our own custom demo message. So now we have Spring Boot on Kubernetes, like that. And we can also add some configuration which don't make sense when we work on a local environment, but when we want to go to production, they are really necessary. One of them is the graceful shutdown feature. So when when a container is shut down, whatever the reason in Kubernetes, we don't want the application to be terminated right away, because if there is any request still pending, we don't want that to be killed, so the user would get some errors. We want to ensure a nice and seamless experience for users, so with no downtime. In order to do that, we need to enable graceful shutdown. So when a termination signal is sent to Spring Boot will stop accepting any new request, but it will wait some time in order for the ones in progress to complete. So the first thing is enabling the shutdown feature, so shutdown graceful. And then we can also configure how long Spring Boot should wait for the current request to complete. We can configure that with Spring lifecycle timeout per shutdown phase. Maybe 15 seconds. And we are missing an indentation there. Yes, we are a bit closer to be ready for production now, but not quite there. So we talked about the different configuration options, but now that we have a config map, we need to provide that to the application. So how can we tell Spring Boot to use the config map? And we have at least two main ways. A first way is using environment variables and getting values for those environment variables from the config map. But that's not really recommended, because whenever a config map changes, Kubernetes will not inform the container that something changed. But it will do that if we use volumes. So we can mount, we can define a volume starting from a config map, and then we can mount that volume to the application. And we're going to do that right now. So we have the config map, is named demo config. So in the other manifest, I'm going to add a new section about volumes. We have a volume, let's name it demo config volume. And the volume is created starting from a config map. And the config map name is democonfig. Then I can mount the volume. So I'll add the section here, volume mounts. And the name of the volume is this one down here, democonfig volume, and then the mount path. So now the path I'm writing here is, there's no magic behind it. I know that when I containerize the application with build packs, the application is put in a workspace folder. That's the first thing. Then I know that Spring Boot automatically by default will look around the folder where it's placed for folders named config. And if there's any property file in that folder, it will read those property files automatically. So just by using this path, I know that Spring Boot will read the properties. But of course, we can use any other path. We just need to remember to inform Spring Boot about the path that we're using. And we can do that with the Spring config import property if you're using a different path. But in this case, we're going with one that we already know that will be considered by the application. So it's getting better, but not quite there yet. We need to talk about health probes. So Kubernetes is really great because if there's any problem with an application, takes care of it. It's the self-healing feature of Kubernetes. But Kubernetes doesn't know when an application is healthy or not. So we need to provide a little help to Kubernetes, depending on our application. And in particular, Kubernetes is interested in two different states. The first state is the liveness state. So when an application is not alive, Kubernetes will restart it, because it means that it entered a very bad state, a faulty state, and it won't be able to recover by itself. So it will restart the container. The other state is the readiness state. And if the application is not ready, it means that it's not able to process any new request, temporarily at least. So Kubernetes will stop sending traffic to that specific instance. And that's really great, so the users will not notice any issues, because we have other instances that will accept the traffic and process the request. The beauty of these two states and working with Spring Boot is that we get them out of the box. Since we added Spring Boot Actuator, Spring Boot will detect when we run on Kubernetes and will expose two HTTP endpoints that return the information about liveness and readiness. So we don't have to change anything in the application. We just need to tell Kubernetes where to look to extract that information. And we can do that from the YAML manifest again. So I'll go back here and I add two new sections. One is the liveness probe and the other one is the readiness probe. So for the liveness probe, I tell Kubernetes to go and send an HTTP GET request to /actuator/health/liveness. And this is exposed by default. If you want this endpoint exposed on a non-Kubernetes environment, you can do that, but you need to enable it via configuration properties. And readiness probe is similar. We still have an HTTP GET request, and the path is /actuator/health/readiness. Perfect. Next, we can configure how or the period and the frequency for Kubernetes to send calls to these endpoints. So I can define some initial delay seconds, for example, and then period seconds, both for liveness and readiness probes. So at this point, let's hope that we get internet back. Yeah, not even my phone is working. That's just perfect. Oh, we got it. So in the meantime, I can talk about how oh, we got it. So let me quickly deploy it before it goes down again. So what I can do now, I can use the Kubernetes CLI. So I can say kube control apply -f and then point to this knative folder. and then it should deploy both resources. But since we have the GitHub Actions pipeline here, I want to show you that whenever I push something to the main branch, what happens is that I have two jobs. The first job is to compile the application and run the test. So here I set up Java 17, and then I run Gradle build, which compiles and run all the auto test. If that is successful, then I have a package job, still using Java 17, and I call the boot build image task. But this time I'm adding two extra arguments. The publish image argument will make sure that this task will also directly publish the image. And then I'm also overriding the image name because I need to use my Docker Hub username in order to publish it. And then I'm also providing the credentials in order to log in with the registry. But this is really convenient. So you don't even need Docker on your local machine. You can work normally on the JVM, then you push your changes, and it's the continuous delivery pipeline that takes care of packaging the application. Oh, that was too slow. Yeah, it was interesting that right before the presentation, it worked, of course. So let's give the Wi-Fi another try. Well, in the meantime, so I'm using this tool. It's called Octant. You can run it on your local computer. It uses the credentials that you have defined in your kube control configuration in order to visualize the workloads in a cluster. So you can use it for a different cluster. It runs on your machine, so it doesn't have all the security issues that in the past we experienced with the Kubernetes dashboard. Line 23. Ah, yeah, the joy of working with YAML indentation. Well, the nice thing is that error messages are really descriptive. Oh, I think that's... Yes. Yes, we did it. We have deployed the application. So if internet will keep working now, we can actually also use it. Let's see what happens here. So what happens behind the scenes, since I'm using this service Knative object, is that Knative will get this specification and will deploy, will create a deployment, a service, an ingress. So everything that you would have done manually and individually for each resource, it does it for you. And on top of that, it also returns a URL that you can use to access your application directly via the ingress controller. So it's really great for development also. So let's see. So it's actually working. So I'm using the Knative command line. I get a URL. Now I can use that URL to call the application. So if I go on the browser and call that application, I get the message, Spring Boot on Kubernetes. That just disappeared. Yes, Spring Boot on Kubernetes. So I get this nice URL back from Knative, and I get the message. The config map is working because I can see the new message, and the health probes also are working. It means that if, for example, the application takes a few seconds to start, right? In those few seconds, the application is not ready. So it means that Kubernetes will not send any traffic to it. But now there's an interesting aspect of using Knative, because probably I need to refresh Octant, because Knative supports serverless workloads. And one of the features that is enabled by default is the scale to 0. When we work with a standard application, that's a bit of a problem, because a Spring Boot application takes a few seconds to start. So it means that if there's no request for a while, there's no instance of application running. But as soon as we send a request, a new application is started, but then it means that as a user, I will experience a delay. I will have to wait a few seconds before getting the response back. And that's really not what I want to provide as an experience, both to users, but also to other applications using my services. So now 1 minute passed. That's the default timeout in a Knative. So since there was no call, I would expect to get a slow response if I call the server again. So you can see that it's waiting. I mean, it might even be the internet connection, but that's my point. We have a problem there. But we have also a solution. So let's move on. What we have done so far is perfectly fine for more standard applications that are long-running applications. We talked about liveness and readiness probes. That's perfect. But now I want to get to Spring Native. Spring Native is this exciting new project that aims at compiling your Spring Boot application as a native image based on GraalVM. So we wouldn't run the Java application on the JVM anymore. We don't have the two steps compilation where we have first the compilation to bytecode, and then the JVM takes care of converting bytecode to machine code. But we directly compile the application down to the machine code. So from one side, we are losing one of the Java features, like write once, run everywhere, because we don't have the Java virtual machine. So I can compile an executable for my MacBook that will not work on Windows. But that's fine because we're in a containerized world, right? So we can build a container with a native executable. So I still get the write once, run everywhere, but I get a lot of benefits at runtime. One of the benefits is instant startup time. Usually with Spring Native right now, it's usually below 100 milliseconds, which is a great improvement compared to now where maybe 2, 3, even 4 seconds we need to wait for an application to start. We also get instant peak performance because the JVM, when we run an application, will need to do a lot of computation at startup dynamically. We don't do that with a native executable. So we also get this instant peak performance. And we also get reduced memory consumption, which is really great. If we are deploying on a public cloud, that means that we're going to save a lot of money because we need much less memory specifically to run applications. Of course, there's no silver bullet. It's always a matter of trade-offs. So since we are optimizing as much as possible the runtime part, we still need to do a lot of those computations that right now the JVM is doing dynamically while running. So we are moving all those computations back to the build time phase. So when we build the application, now we get a slower and heavier process. So it can take even a minute or 5 minutes depending on the resources on your computer. It consumes a lot of CPU, it's slow, and well, it's a good job for a CI server probably, but if you want to do it on your machine every time you need to containerize it, then maybe it's not that efficient. So it's just something to consider. It's improving over time. They're working a lot on optimizing the build time, both for GraalVM, but also the Spring Native project. But right now, we need to consider that. Also, there are less memory, less runtime optimizations right now, because the JVM can dynamically figures out a lot of things at runtime, depending on how things are running. So since we are now moving everything in the build phase, we need to do it in a static way. So we are missing some opportunities to further optimize the code. The goal of Spring Native is to achieve these native executables without changing anything in your code, at least when in regards with all the libraries which are provided by Spring, either Spring libraries or the third parties used by libraries, part of the starter projects. So what I can do now with the applications that I've just built is add the Spring Native dependency and changing nothing else, and it will work in the same way. I can use the same task, boot build image, to containerize the image as a native image, and it will do that because I add Spring Native to the project. So you can add a Spring Native dependency from here. The project is still in beta, but I know that it's also being used in production already. It will be out of the experimental mode next year, so it will be included as part of the Spring core in the next major version of Spring. So we're talking about Spring Framework 6 and Spring Boot 3. But for now, it's in beta. So if you add this one, then you'll get everything you need to compile to a native images a Spring Boot application. So I have already done that. I just changed the name of the application. It's called Demo Native instead of Demo Service. So I can show you that the Java code is exactly the same. We have the configuration properties record. It works with Java 17, by the way. We have the REST controller. We have the custom application. You can see I have defined the name of the application also. And we have the test. Also, the tests are the same. So what changes is something in the build Gradle file, because when we add Spring Native, we get 3 new things. 2 of them are plugins, either for Gradle or Maven. We have the Spring Native plugin, which is responsible for doing all the native compilation for the Spring libraries. And the other one is the GraalVM official Gradle or Maven plugin that lets you build and run tests on a native image on your local machine, in case you want to do that. And then we also get this additional configuration for the boot build image task, so that using this environment variable, we set the native image to true, and we can run it, and we can obtain a containerized image, which is a native executable. Let's see if internet is still with us. So for this demonstration, I will use the knative command line. I could do the whole manifest thing, but I want to show you another way of doing it. This is especially useful in development, so I wouldn't use this in production, but it's an option that you have when you're working actively on a new application. So I can say kn service create. We want to create a demo native, and then the image. So this is also something that GitHub Actions push to my container registry. So for clarity, I will also undeploy the other one. Yeah. Oh, it works. So the previous application was starting in 3 seconds, roughly. So we can now see the startup time of this application. So we get a URL back. So first I can verify that it works. And then I can, yes, Spring Boot on the cloud. So it's still the default message because right now I deployed directly the image. I didn't use any config map. And then in Octant, I can check the logs. So we can see the startup time. Container, no, not that one, this other one. Yes, so we can see that this one started in 0.1 seconds, and which is really also a long time. It usually runs in 50 or 60 milliseconds. But so just by adding the Spring Native dependency to the project, I got this application which is now suitable for a serverless use case. So I have Knative, so I can rely on the scale to 0 feature. I save money on resources because if there's no request, then there's no pod running for my application. And I didn't have to change anything in my code. And that was our cloud native journey. We started from Spring Boot. We built a cloud native application. We even briefly looked at Spring Native. Without changing any code, we got a native executable. We used cloud native build packs in both cases to containerize the application. So we didn't have to write a Docker file. We don't have to maintain the Docker file. So as developers, we are free to focus on the business logic. And we deployed the application on Kubernetes, in particular a Kubernetes cluster on a public cloud, Azure, with the additional layer of Knative, which gives us a better experience and extra features. Thank you, and enjoy the conference.